All right, we're reviewing graphing exponentials with transformations. So we're taking a basic exponential and changing it by multiplying, adding, or subtracting in the exponent or after, and what each one means. So we're going to go one at a time here. When you multiply in front, if that number is bigger than 1, then that creates what's called a vertical stretch. And if that number is a fraction less than 1, it creates what's called a vertical compression. If that number is negative, it creates a reflection. And it reflects across the x-axis. So if we have a number, and so when we take the number, we really take the absolute value of that number, just what the number is. Don't worry about if it's negative, it means a reflection, just the number without it being negative. If that number is bigger than 1, it's a stretch. If it's less than 1, it's a compression. And this only affects the y-coordinate. So it tells me whatever the a value is, you multiply it times the y-coordinate. Now the h is a horizontal shift. And it goes in the opposite direction. So if you see subtracting, that means it's going to the right. And if you see adding, that means it's going to the left. So we have to be careful of that. K is the vertical shift. And it does what it says. So it's going to go up if it's positive, and it's going to go down if it's negative. So press pause if you have to. Those are the three things. Now H affects the x-coordinate, and K affects the y-coordinate. So the only thing affecting the x in this situation is the H, and affecting the y could be two numbers. So you might have to multiply first and then add and subtract if you have both going on. So let's look at this really quick. So I want to graph this function, and I want to understand what the steps are. So here we have an exponential with changes to it. So first we write down the basic exponential, and we write down 2 points that go with it. So 0, 1, and 1 and the base, and the asymptote. So that's from the other lesson on graphing a basic exponential. Then what changes took place? From there, how did it change? And so it changed by subtracting 1 and adding 3. So this goes the other direction. So it's actually positive 1. It's going to the right. This is going up 3. This affects the x, and this affects the y-coordinate. So when I come here, I go, okay, 0, I'm going to add 1. And here, I have 1, and again, I'm going to add 1 to that x. To the y-coordinate, I'm going to add 3, not subtract here. So I'm going to add 3 and add 1. So 1 plus 3, and 2 plus 3. To the y-coordinate again, I'm going to add 3. So now the asymptote is there at 3. So when I graph this, the graph is going to start at 3. Right there is the asymptote. And then you're going to plot the other points there. So 1, 4. So 1 to the right and 4 up. And 2, 5. So those points, that asymptote you're going to use. So it's still going to curve up to the right and then follow the asymptote to the left. So we have those. And this has been shifted 1 to the right and 3 up. If I want the domain, again, it's all real numbers. The range, this one I have to think about, it starts at the asymptote and goes up. So the asymptote's at 3. So it goes 3 to infinity. The end behavior, as x approaches infinity, the right end goes up. As x approaches negative infinity, this one's going to be a little different. So the left end goes to the asymptote, and the asymptote is at 3. So it doesn't go to 0 in this case. And the y-intercept, I won't ask for, and the asymptote, we already said, is at y equals 3. So we need to focus in on this. Let's try another one together. So I want to graph this, and I want to know what the steps are. So the step 1 is to write down the basic exponential. That's just 1/2 to the x. I need to know 2 points and an asymptote on that basic exponential. So 1 point on every basic exponential is 0, 1. And the second point, because the base is smaller than 1, we're going to use -1, and we're going to do the reciprocal of 1/2 for the y coordinate. The asymptote for an exponential is always y equals 0 for a basic one, and then we're going to change this. So to change this, I need to know what is involved, what's changing what. So notice one change is multiplying, that's a, by -3, and the second change, we're adding 2. Now, we're going to go in the opposite direction of what's in that exponent. So we're actually going to subtract 2. So we have -3 and subtract 2. So to the x coordinate, we're going to subtract 2. So 0 subtract 2 and -1 subtract 2. To the y coordinate, we're going to multiply. So we're going to go 1 times -3, and we're going to go 2 times -3. I want you to notice when you multiply 0 times -3, it stays 0. So when you multiply, the asymptote stays where it is. It's only when you add or subtract at the end that shifts the asymptote. So that when I graph this, here at 0, I wonder if you can hear the water polo practice partying away to music, which is fun. All right. So plot -2, -3, plot -3, -6, and then the graph is going to curve. Because there's a reflection, instead of going up, it goes down, and here's the curve of an exponential that's been reflected across the x-axis. So the domain stays the same. The range goes from the bottom to the top, so it goes -infinity up to 0, and the end behavior. So the right end is going to 0, and the left end is going to -infinity. So the right end is going to 0, and the left end is going down. All right, so I hope that helped. That was a quick review. If you need more practice, you're going to have to go back to the actual lesson and the actual homework, and then go slowly over them a second time. All right, Mr. G Math, over and out. Till next time.